We are working here today. We will be graphing some exponentials. This video, frankly, is suitable. This is a review lesson. If you're in a 3C class, if you're in a 2D class, maybe you have covered it a little bit more recently. But either way, we're working here. We're going to rely on some prerequisite skills. We'll assume you're comfortable working with a Cartesian coordinate system. We'll assume you are comfortable working with substitution from x values into an equation. So we'll jump right in. We will review. A linear function has the same first differences. Now, first differences are just how your y value is changing for each successive x value. And that means, okay, x is going up by the same amount every time. In this case, x is going up by 1. That's great. That's required in order to work with our first differences. Then we say, okay, how is our y value changing every time? Well, let's cross out this first one. There is no first difference for the first point. But then we're saying, okay, this second point, where did it come from? Okay, so in order to get up to 21, what did it do? Oh, it started at 17, and here's our key, and then it went up 4. So we would say our first difference is plus 4. And then we say, okay, this 25, where did it come from? Oh, from 21, it went up 4. Okay, so our first difference is plus 4. Same thing, 29, we're going up by 4. Same thing, 33, we're going up by 4. Now, if you have a linear function, then your first differences will all be the same. So we have ourselves there a linear function. Great job, us. All right, a quadratic function should have the same second differences. I want you to start off the very first step here in order to find your second differences is to calculate your first differences as we just did with our linear function. So I encourage you, pause the video, unpause, see how you did. From 17 to 20, we're going up by 3. From 20 to 21, we're going up by 1. From 21 to 20, we're going down by 1. So it's a negative here. And from 20 to 17, we're going down by 3. Great. Now our second differences just come from doing that exact same process, but instead of using our y value to see how it's changing, we're going to use our first differences to see how they are changing. Well, nice and easy. We're working from plus 3 to plus 1. What's happening? Oh, it's gone down by 2. From plus 1 to minus 1, what's happening? It's gone down by 2. From minus 1 to minus 3, from negative 1 to negative 3, we're going down by 2. These are our second differences. These are the same. These are constant. That's what tells us we have ourselves a quadratic function. So we can do this analysis in order to take a look at a table of values and determine what kind of a function we have, whether we have a linear function or not, whether we have a quadratic function or not. We know how to do that from using our first and second differences. Now, a common ratio. Again, it comes from, we were working with successive y values and we were subtracting them in order to find these differences. You may not have performed subtraction yourself. You may have just in your head said, hey, how does it change? Either way, we're working here. This time, if we're working with a common ratio, instead of subtracting successive values, we are going to divide successive values. If these values are the same, then we have an exponential function. So let's take a look here. We're going to work with our first table of values. We're going to find the first differences first, and then we're going to take a ratio of those pieces. So your first differences, pause the video, unpause, see how you did. You know how to do this now. Good. Now our ratios. What we're going to do, we're going to take successive values. That means one after the other, and we're going to divide them. In this case, we're going to work with the second number first. So we always go up, all right? So we're working from 6 to 3. We throw into our calculator 6 divided by 3. What do we find? 2. All right, nice work. Then let's try that again. We're going to take 12. We're going to divide by 6. What do we get? 2. Okay, and here's our big check. 24 divided by 12. What does our calculator say? 2. These values, these are what we're checking. And again, we divided in order to get these. These are the values. If these are the same, we have ourselves an exponential function. So we could say at this point, yes, this is an exponential function. Good job. Part B, we're going to try. I don't want you to get too far ahead of me here because there's going to be an interesting case coming along. I want you to calculate your first differences, and then I want you to unpause and see that your first differences were the same, and then we're going to see how we do. Good, okay, now that our first differences are the same, what's our conclusion? Oh yeah, remember, we already did something like this. We were working with the same first differences with a linear function. If our function is linear, then it is not. I'll repeat, if our function is linear, it is not an exponential function. So here we would say, okay, this is linear, not exponential. I want you to try out C. I want you to pause the video, unpause, see how you did. Good, we have ourselves an exponential function here. Again, part D I want you to try on your own. You'll notice I've left these titles blank. You know what to do. Good, again, we have ourselves an exponential function. Fantastic, we feel pretty darn comfortable. Question 2, we're going to work with these equations and we're going to fill in our table of values. You'll notice we have ourselves some extra columns. We know what we're going to do with those. I encourage you. If you feel comfortable with this, pause the video, see how you did. But otherwise, you're working with me right here. And we're working with y equals 2 to the exponent x. And our first x value we're using is -2. So really, we're working with, if x equals -2, then we're working with y equals 2 to the exponent -2. Oh, hang on, you're not brand new to this course. We've already covered how to handle our negative exponents. That is, we're working with 1 over 2 to the exponent 2. Oh, we're working with 1 over 4. Nice work, us. All right, moving right forward. Then instead of using a 4, instead of using a 2, instead of using a -2 up here, we're going to work with our next x value. That's -1. -1, we have 2 to the exponent 1. That is 1 over 2. So we're working with a y value 1 over 2. All right, I want you to keep right on going forward. Pause the video, unpause, see how you did. All right, now, nice work. Now we're going to be working with our first differences. We're going to see how these come out. You know what you're doing here. Go for it. You could choose at this point to work in decimals. You could take 1 over 4, use 0.25, work with 1 over 2, use 0.5, work your way forward. You might end up with these first two cells saying 0.25 and 0.5. That's perfectly acceptable. We did not because I didn't work with decimals. That's okay. I'm not afraid of fractions. Good. Our first differences, are they the same? No, absolutely not. Okay, so that tells us that it's not linear. Now we're checking to see if it's exponential. We already know we're expecting it's exponential. Let's, I encourage you, pause the video. Show me how you know that this is exponential. Good, we're seeing our common ratio pop up. These are all the same, so it is exponential. Now, let's look and see what it really looks like if we plot these points. The coordinates we're concerned with are just the x and y coordinates, okay? So as much as we calculated our first differences in our ratio, that's great. That's really helpful to tell us whether we're working with an exponential. But now we're looking, if we're putting it on a graph, we don't care about those two columns anymore. We're just working with our coordinates. We're working with -2, positive 1/4. That's less than 1, that's more than 0, and it's a little bit closer to 0. Working our way forward. Good, you're seeing this pattern. If we actually continued, which I kind of wish that I'd left this space, whoops, I'd gone into an x value of 4 right here. If we had continued, we'd end up with 16. We'd end up with a point right here. If you didn't choose to do that, that's fine. But you can see this nice general shape. It goes from really flat to really, really steep. That is the shape you can expect with an exponential. All right, you've seen a quadratic before where it's steep on both left and right sides. This is not a quadratic we're working with because it's flat on one of those sides. All right, that's how you can tell the difference when you're working with a sketch. I encourage you, pause the video, try out our second equation right here, y equals 1/4 to the exponent x, and unpause to see how your y values show up. All right, we're working with some pretty wonky numbers. That's okay, we're not afraid of wonky numbers. I'm hoping you used your calculator there. As we work forward, we can continue. You know what to do with your first differences. Go for it. All right, nice work. You found your first differences. We're going to try and check out our ratios. I encourage you, pause the video, see how you do. Good, okay, now we're recognizing, okay, our ratios, they're all common, they're all the same. That means we have ourselves an exponential function. Now, I'm hoping you can recognize here, hang on, last time we were working, our common ratio was 2. This time we're working, our common ratio is 0.25. 0.25, what is that? Oh, that's the exact same as 1 over 4. Right, this 2, what is that? Oh, that's the exact same as this base. right? So our common ratio is actually the exact same as our base. Now, that's all well and great, but again, we're not focused on the first differences or the common ratio as we move forward into a sketch. We're just focused on our x and y values. Again, I encourage you, pause the video, try and plot these on a Cartesian plane. If you're struggling to plot these on a Cartesian plane, you need more practice. Make sure you're completing all of your practice work there. Let's see. Now, you might be really uncomfortable plotting these numbers. They're super, super small. That's fine. We're not afraid of that. Super small numbers, they're in between 1 and 0. They're way closer to 0, so that's what we're doing. We're just putting our points really close to that x-axis. Now, again, this general shape. We see a nice flat end right here. We see a nice steep end right there. Those are the shapes that we're expecting when we're working with an exponential function. I'm hoping that at this point you recognized, hey, the flat side does not need to be on the left or the right. It can be on either side. The steep side, same thing. I'm hoping you feel more comfortable at this point working with a table of values with an exponential relationship and putting them on a Cartesian plane. Nice work.